A very good morning. The topic which I am going to take today is basically second chapter of NCERT, electric potential and capacitance. We already finished electric field, and we said electric field is what? It is the force experienced by a test charge. If you keep a test charge, the force experienced by a test charge per unit test charge, that is electric field. So basically electric field is a measure of force which a given charge will exert on a test charge. We will discuss today what is electric potential. This is the second important term in electrostatics. Electric potential. We discussed the word potential when we studied gravitation. Gravitational potential we discussed. We said gravitational potential is what? We said gravitational potential is the work done to bring a test mass from infinity to a point per unit test mass. That is what gravitational potential is, isn't it? So gravitational potential deals with mass. When we talk about electric potential, it deals with charge. So how do we define electric potential? Electric potential is the work done to move a test charge. Work done to move a test charge. Q0 is a test charge from infinity to a point, a given point, let's say A. Work done to move a test charge from infinity to point A. To point A. Infinity to a point A per unit given test charge. Now this expression will give you what? Potential at point A. Now potential at point A due to what? Due to the given charge. So potential of this charge at a point, potential of this charge at a point is the work done to bring a unit positive charge called test charge from infinity to this point per unit given charge. I think that is the basic understanding of potential, isn't it? Similar to gravitational potential. Now let's say if I choose a point A and I choose a point B, I am very sure the distance of point A from the charge is RA, from B it is RB. So if I have to shift a test charge, which is a positive charge, to B, I will have to do less work. But if I have to shift this charge Q0 from infinity to A, I have to do more work. For obvious reasons, this charge is going to repel the positive charge. So since I have to do more work to bring the charge to A than to B, the potential of point A definitely will be more than potential of point B. Right? So the potential, which is the work done to move a test charge from infinity to a point unit test charge, will be higher at A compared to B. Now the point of discussion is, what we have to do here is, we have to find the first topic, the potential difference between point A and point B. We need to deduce the expression of potential difference between point A and point B. I made it clear that potential at A will be more than potential at B. So now what I will do is, I will try to derive the expression of potential difference between B and A. What I want you to understand and remember and think is, when I take a charge Q, the electric field of the charge is in the direction I am showing. This is the direction of electric field. So as I move away from the charge, the electric field strength goes on reducing. Or I can take it this way, when I move this charge from infinity towards this given charge, the electric field strength of this charge goes on increasing. That means at different points, the value of electric field is different. Electric field is different means what? The force which this charge is going to exert on Q0 will be different at different points. So the force is variable. The force which this charge is going to exert on Q0, the moment it is brought into the field, this force will be a variable force. So when you talk about a variable force, and when you talk about work done, we have already discussed the work done under a variable force. When you have to deduce the expression of work done, which we need to deduce, we have to deduce the expression considering the force to be a variable force. So what we do here is, we choose a small elemental elemental displacement. Let's say we take it dr. We choose a point here as r. Let's say this point is your point number 1, this point is your point number 2. I have to displace the given charge q0 now from between 1 and 2. I have to consider an elemental displacement since it is a variable force. So I'll find out work done to displace q0 from 1 to 2. I'll find out work done. So that work done will be what? dw. The work done dw, elemental work done from 1 to 2 will be what? F external, which I am applying, dot dr, isn't it? F external dot dr. Clear? F external dot dr is a, let's keep it, let's not use vector, let's keep it as simple as possible. Let's take it simply F external into dr. This is a work done to move the test charge from 1 to 2. Now I have to find out these incremental work done right from B till A and add all those dw's to get the total work done to move the charge from B to A. Since my point is I have to find out potential difference between A and B. So potential difference between A and B will be what? Potential difference between A and B will be work done to move a test charge from B to A per unit test charge. Right? So potential difference between A and B is the work done to move a test charge from B to A per unit test charge. So my main objective is to find out work done between B and A. So this is how I am proceeding. dw from 1 to 2 is F external dr. Now what is F external? F external is the force which I am applying to move the charge from A to B. So if I have to write my external force in terms of electric field, which is exactly opposite to my force, can I write F external is equal to minus q0 into electric field into dr? Now why did this minus sign come? I am applying a force against the field. So the moment I use the term electric field, a negative sign comes in. My force is against the field. So if field is from my left to right, my force is from right to left. So I will have to use a negative sign for electric field. So minus q0 E dot dr. Now what is electric? What is E? Now E at this point 1. E at point 1 is nothing but k q by r square. Isn't it? This is dw from 1 to 2. So minus q0 k q upon r square dr. So minus k q q0 upon r square dr. This is work done to move the test charge from 1 to 2. To find out the total work done from B to A, what do? We put an integration sign. Integrate 0 to w from what? I have to start from B. So B is RB. RB to RA. Isn't it? The limits will be from RB to RA. So integrate dw, what do we get? We get work done. Total work done from 0 to w is equal to minus k q q0. K is a constant, Q is a constant, Q0 is a constant. They can come out of the integration sign. Integration from RB to RA dr upon r square. Right? So I'll take this further. Minus k q q0. What is integration of dr by r square? I can take it as, show the integration step also, r raised to minus 2 dr from RB to RA. This gives you what? Minus k q q0 r raised to minus 2 plus 1 upon minus 2 plus 1 from RB to RA. This gives you minus k q q0. This is minus 1 by r from RB to RA. This minus minus goes off. What do we get? K q q0 1 by r from RB to RA. Right? This is RB to RA. If I substitute the limits, I get work done W. So this is what? W minus 0. So that is W. Now what is this W from B to A? Isn't it? This is work done from B to A. Work done from B to A is equal to K Q Q0 1 by upper limit RA minus 1 by lower limit RB. So work done from B to A is equal to K Q Q0 1 by RA minus 1 by RB. Now this is work which I have to do to move the test charge from B to A, isn't it? But this is not potential difference. What is potential difference? We said potential difference is basically, what is potential difference? Potential difference between A and B is the work done to move the test charge from B to A per unit test charge. So I write VA minus VB is equal to WBA upon Q0, and we already used the term WBA. So let me substitute the value. VA minus VB is equal to K Q Q0 1 by RA minus 1 by RB upon Q0. You cancel this. K Q 1 by RA minus 1 by RB. That becomes your expression of potential difference between A and B. Logically also, if you see, RA is smaller than RB. Since RA is smaller, this term will be bigger, isn't it? If I expand this term, KQ upon RA minus KQ upon RB. Clearly this term is bigger than this term because RA is smaller than RB. Okay, RA is smaller than RB. So this term is bigger than this term. That means potential at A is more than potential at B. So you need to copy this derivation. It's a very important derivation. The same derivation I'll try to find out even the potential at a point. I'll also try to find out the potential energy between a given charge and between the given charge and the test charge, and also try to prove a few more things which are asked in the board exams, isn't it? The potential, this derivation is also given on page number 53 and 54. You have to go through page number 53 and 54, 53 and 54 of NCERT textbook. You'll have to go through page number 53 and 54. Okay, I think I'm clear with this. So I'll switch over to the next part of the same chapter. Now I deduced what? I deduced potential difference between 2 points, isn't it? Now I'll try to find out the potential at a point, electric potential at a point. Now what is electric potential at a point? As I state the definition, electric potential is what? Electric potential is the work done to move a test charge from infinity to a given point A per unit test charge. So what is the difference between this derivation and the statement which I am making? When I say potential difference between 2 points, it is the work done to move a test charge from one point to the other per unit test charge against the given electric field, isn't it? I moved against the electric field. Now what I am saying is electric potential at a point. It is the work done to move a test charge from infinity. So my initial position is infinity to a given point, isn't it? So I'll just simply write here. Let's say when I say I am trying to find out electric potential, I can use this black one. When I say electric, this is my second topic, electric potential. Page number, you can note this, page number 54. It is given 54. Electric potential at a point. When I try to find out, I say it is a work done to move from infinity to A. So I have to do the same derivation again, with the difference that this RB will be replaced by infinity, isn't it? Because now I am moving from infinity to A. I am not moving from B to A. So the only change that comes here is instead of RB I will put infinity. So I will try to make this change. I will just remove RB from here. So I will put infinity here. Rest remains the same. I will put RB. I will remove this RB here. Oh sorry. I will put infinity here now. Put infinity. So the moment I put infinity here, what happens is this term goes off. because we all understand 1 by infinity will be 0. So switching over from here to here now. Work done not to move from B to A, now it is work done to move from infinity to A, infinity to A, infinity to A. Okay, infinity to A. Isn't it? This is the expression of work done. So when I say potential at a point, what happens is potential at a point is Q0 upon RA upon Q0. This is potential at A. So this goes off potential at A. The expression of potential at A is KQ by RA. So simple. So potential at a point is defined as the expression of potential at a point is KQ by R squared. We said what is force? Force is KQ1 Q2 upon R squared. What is electric field? We said electric field is only KQ by R squared. See these terms, square, R square, R square. When you talk about potential at a point, it is KQ by R, isn't it? Fine. So this is deriving the expression of potential at a point. So we did two expressions. It was a little comfortable for me since I could erase the board and rewrite the term infinity instead of RB, but you will have to write both the derivations in your notebook separately. First you write the expression of potential difference between 2 points, VA minus VB, which is here, and then you write the second expression, write the heading as electric potential at a point, rewrite the whole thing and find the expression that is KQ by R. Isn't it? So we are done with two parts. The next topic which I wish to take up is there's a question which comes in CBSE boards. Prove that electric field is a negative differential gradient of potential. I'll repeat the question again. Prove that electric field is a negative differential gradient of potential. When I say the word gradient, that means what? Divided by dr. Differential matlab d by dr. Differential means d by dr. So what they are asking you basically is, what they want you to prove is, I'll just erase this off. What they want you to prove is, okay, I'll rewrite it again. I'll take the same diagram. See, I'm not changing the diagram, I'm keeping it same. So what they are asking you to prove is, prove that electric field E is the negative differential gradient. Differential gradient of what? Of potential at a point. Or they may ask you a straight away question, prove that E is equal to minus dV by dr. When I write this expression, it should click to your mind. We did a topic in class 11, work, energy and power, in which we did conservative forces, isn't it? Conservative force. What are the properties of conservative forces? Properties of conservative force, the work done by the conservative force does not depend upon the path. It only depends upon the initial position and the final position. One of the properties. Another property which I made you write is that F is equal to minus d by dr of u, potential energy. I hope you remember. You can go through the notes again. Force is minus d by dr of u. Now if you carefully see here, if I divide this with q0, what is potential energy? Is basically work done when I divide by u0. Work done by q0 gives you what? Potential. So this becomes what? E is equal to minus d by dr of v, isn't it? So dimensionally, this can be easily reduced. So that means another question that comes to my mind when I write this expression is, one question I said E is a negative differential gradient of potential. Question 1. Second, they may ask you, prove that E is equal to minus dV by dr. Or third, they may ask you, prove that electric field is conservative in nature. Isn't it? So they have they have jumped from one question to the other question to 3 questions. It can be a 2-mark question, it can be a 1-mark question, it can be a 3-mark question. You'll have to write accordingly. So, what we are going to prove here is, when we derive this expression, we'll prove that E is equal to minus dV by dr. Definitely a straightforward question. Or they may ask you in a statement form, E, electric field is a negative differential gradient of potential. Or they may ask you, prove that electric field is conservative in nature. When we say electric field is conservative in nature, that means the work done by the electric field or against the electric field is independent of the path. It depends only on the initial position and the final position. That means if I have to prove that this is conservative, I'll have to justify that my work done to move from B to A does not depend if I move straight, or if I jump from B to A, if I start from B, go to China, come to Italy and come to India. I hope you got my point, isn't it? So wherever I go, my work, the work done by me will depend only on B and A, only on this path, only on the displacement, not on the path which I follow, isn't it? Okay, we will try to justify this expression now. How do we justify? Again, we start with dW. To move from 1 to 2 is what? It will be F into dr, as we said. What is F? Minus Q0 E into dr. I hope now you know why we are using the term negative here. Force is external, electric field is against, my force is against the electric field. So now dW 1 to 2 is minus Q0. Oh, I'll mark here 2 important things. Now, one thing is for sure, that if I choose point number 1, this is my point number 1, isn't it? This is my point number 1, this is my point number 2. Let potential at 1 is V volts. Okay, volts is the unit of potential. So I can write, when I say V, it is work done by Q0, and we know work done means joules, coulomb. So volt is equal to joule per coulomb. This is the SI system, right? Let potential at 2. If potential at 1 is V, definitely potential at 2 will be more than 1, isn't it? So let the potential at 2 be V plus dV. Because I am taking an incremental distance, so I am taking an incremental increase in potential, isn't it? So dW 1 to 2 is equal to minus Q0 E dr, as we wrote. Let me divide this Q0. Put this Q0 here. This gives me what? Minus E into dr, isn't it? So what is work done from 1 to 2? I think work done from 1 to 2 per unit Q0 will give me potential at 2 minus potential at 1, which is minus E into dr. Fair enough? Work done to move from 1 to 2. From 1 to 2 is work done to move from 1 to 2 per unit test charge is potential at 2 minus potential at 1. Right? So now V2 minus V1 we got is minus E into dr. What is V2? V2 is V plus dV. What is V1? Definitely V minus E dr. This term cancels out. dV is equal to minus E into dr. Clearly E is equal to minus dV by dr. So the expression proves that electric field is conservative in nature because this is the property of conservative fields. We also prove E is equal to minus dV by dr. Isn't it? So if they ask you a question of 3 marks, maybe I can solve this. If they ask you a question of 1 mark, prove that electric field is conservative in nature. Very simplest way of proving, you can say, according to the expression of potential, which is work done, that's a potential difference. If they ask you electric field is conservative in nature, that means what? Work done by the electric field or against the electric field is independent of the path. That is what we have to prove. Once we prove work does not depend upon path, it depends upon the initial point and final point, our job is done. And we say according to expression of work done from B to A. B to A. Work done is equal to K Q0 1 by RA minus 1 by RB, isn't it? This is the expression of work done against the electric field. Clearly this work done depends. This will change only if RA changes and RB changes. The part does not come into picture. If I jump my charge from B, as I said, B to China, China to Italy and to India, even if I follow this path, the expression of work done remains the same. If I move straight from B to A, still RB and RA remain the same. So work done does not depend upon the path which I follow. What work done depends on is the initial point and the final point. So since work done is only a function of RA and RB and RA, we can say the electric field against which this work is done is conservative in nature, isn't it? Okay, so we have discussed number of questions related to your CBSE board exams. I'll just move on with one more important topic. I'll just erase this off. You can just note down all these derivations, taking a pause in the video. So, another important topic which I wish to cover here is the concept of potential energy. The concept of potential energy between a system of charges. Now, if I look at the last 3 years CBSE papers, every year they ask you a question. This year also they ask you a question. Only the language of the question changes. Like we know how do we find out the gravitational potential energy between a system of masses. In a similar fashion, we'll try to find out the electrical potential energy, electrostatic potential energy between a system of charges. Let's say the topic is potential energy between a system of point charges, isn't it? So that's my heading. One thing which I again wish to make you clear about is that potential is work done by charge, isn't it? So if I ask you that the potential at a point is V and I have to bring a charge Q, that is potential multiplied by Q will also give you work done. I think you remember class 10 questions. If you recall a few questions of class 10, let's say if you have a plate of 10 volt, that means the potential on the plate is 10 volts and I have to keep a 2 coulomb charge on this plate. If I have to shift 2 coulomb charge on this plate of 10 volt, what is work done? In simple unitary method, if I see work done to put a charge Q0 to a point where the potential is V, that work done is nothing but V into Q. I think if you recall your class 10 Electrostatics chapter, you have this formula there. Potential is work done by charge. So work done is potential into charge. So similarly, if I have to put a Q of 2 coulomb on a 10 volt plate, the work done will be potential which is 10 into the charge which I am doing. So that will be 20 joule. This is a simple unitary way of finding out work done. This work, when I keep this charge on this work becomes a potential energy between this charge and the plate. This is what I am trying to deduce the complete concept. It's a very, very important topic from CBSE boards. Okay, so I'll start off with the concept. The concept is, I'm sure you recall from class 11th also, I discussed a similar potential in gravitation, similar concept in gravitational potential energy also. Let's say I have a system here, a system in which you have no charges. Since there is no charge, I'll choose a point here, point 1, where I wish to keep a charge Q1. So I wish to keep a charge Q1 at point 1, what is the work which I have to do to keep this Q1 at 1? Now, since there is no charge here, that means there is no force, there is no agency which is going to oppose the movement of this charge here, there is no electric field. So very clearly the work done to bring the first charge at point 1 will be 0. I think we will understand. There is no opposition. Till there is no friction, I need not do any work. Till there is no field, I need not do work to push this to point 1. But once I keep Q1 here, I have kept now Q1 at point 1, and I choose a point 2 here, which is at a distance of R12 from 1. And I plan to shift Q2 to 2. Now my point is, I wish to push this charge Q2 to this point 2. But 2 will experience a potential due to 1, isn't it? What is potential at 2 due to 1? Potential at 2 due to 1? I think potential at 2 due to 1 will be K Q1 by R12, isn't it? This is a potential at 2 due to 1, K Q1 by R12, isn't it? So the potential here is K Q1 by R1. I have to put Q2 here. So what is my work done to push this Q2 here? I think we understand it will be Q2 multiplied by potential at 2 due to 1. Fair enough? Fair enough. So this will be what? This will be Q2 into K Q1 by R12, which gives me K Q1 Q2. K Q1 Q2 upon R1. Similarly, so I will place Q2 here now. So I have two charges here. I will choose another last point 3 here, which is at R13 from here, R23 from here, and I have to put Q3 here. On the similar logic, what I will do is work done to move the third charge will be Q3, which I am moving into potential at 3. Isn't it? Potential at 3. Now what is the potential at 3? Potential at 3 now will be potential due to this plus potential due to this. Superposition will be applied. This 3 will have the effect of this potential of 1 and potential of 2. So I will write here Q3 potential at 3 due to 1 plus potential at 3 due to 2. So this gives me what? Q3. What is potential at 3 due to 1? K Q1 upon R13 and K Q2 upon R23. Isn't it? So the work done W3 will be K Q1 Q3 upon R13 plus K Q2 Q3 upon R23. So I keep Q3 also here. So now I have placed Q1, I have placed Q2, and I have placed Q3. If somebody asks me what is the total work done, obviously W1 plus W2 plus W3, which will be clearly equal to 0 plus K Q1 Q2, K Q1 Q2 upon R12 plus K Q1 Q3 upon R13 plus K Q2 Q3 upon R23. Isn't it? This work which I have done has been stored as the potential energy of the system of 3 charges. Isn't it? So potential energy, if you have a simple triangle, maybe 2 coulomb, 3 coulomb, 4 coulomb, 2 centimeter, 2 centimeter, 2 centimeter. They ask you what is the potential energy of the system of 3 charges, 2, 3 coulomb and 4 coulomb. It will be K 2 into 3 by 2 plus K 3 into 4 by 2 plus K 2 into 4 by 2. So that is the basic concept of potential energy between a system of charges. You can revise your class 11th potential energy between system of masses. It's similar, just replace mass by charge. Okay, so I'll discuss more about this in the next lecture, where I'll be taking questions based on potential energy between system of charges. I'll be taking questions based on potential at a point and a few more topics. So wait for the next video, revise these topics. See you again.